Hey everybody, it is day 15 of our meteorology unit. It's the last day of the unit, and today we're going to be talking about predicting weather. So we're going to be putting everything together that we've been talking about this unit, and we're going to take a look at how meteorologists can take a look at weather maps in order to make predictions and forecasts about the weather that places will be experiencing based on the data that they have. So let's just take a look at a number of practice regions questions and practice everything that we've learned this unit. So in this first series of questions from June 2013, we see two fronts extending from a low pressure center and points A, B, C, and D. 36. Which atmospheric conditions describe the air mass that's influencing weather conditions at location C? Well, this is very close to a maritime tropical air mass. Maritime means that it was formed over the water, so it's going to be moist or humid. And tropical means that it was formed near the tropics, so it's going to be warm. So the best answer for that one would be choice 4. Which locations are most likely experiencing precipitation? Well, that would be any location that's located on one of these fronts. So the best option for some location experiencing precipitation would be B and D, choice 4. C is pretty close to this warm front here, but the warm front, the half circles of the warm front are pointing towards D, meaning that's the direction that the front is moving. So that is the area that will get that precipitation. C already got the precipitation experienced with the warm front, which is long periods of light precipitation. B is next to a cold front, so they're going to be experiencing a short period of relatively heavy precipitation, maybe some thunderstorms. 38. Which cross-section best describes the frontal boundary, which is FB, and general pattern of air movements between locations C and D? Well, this symbol here, those like half suns, tell me that it's a warm front, and it's moving towards D because that's the direction that the shapes are on the line. So a warm front shape is going to be this slanting shape. This I call like the steamroller. This is the cold front shape, where that cold air is going to push the warm air up very abruptly. For a warm air mass, we have that slanted frontal boundary, and C is moving towards air mass D. So the best option here would be choice 2. Let's look at another one from January 2018, another series of questions. So we have a high pressure system and a front being shown. And let's take a look at these 3 questions. So 76 says, complete the table in your answer booklet with the actual weather conditions being represented by the weather station in Atlanta, Georgia. So I just made it a little bit bigger so it's easier to see, so we can put it in here. Remember, air temperature is just going to be right in the top left in degrees Fahrenheit, so no math that we need to do there. That's 58 degrees. The barometric pressure, we will need to do a little bit of annotating here. So if it's 232, that means I need to put a 10 in front of my number, and I'm going to add a decimal point between the last 2 digits. So if it's shown as 232 in the station model, it means that the actual value is 1023.2 millibars, which is a pretty high, relatively high air pressure. The wind speed being shown on this station model is with the feather. So I have a whole feather for 10 knots and a half feather for 5 knots. So add them together, that would be 15 knots. And the direction that the staff is coming off of the circle will be the direction that it's coming from. So it's coming from the northeast, because north, south, east, west, that's right in between north and east. 77, the type of front being shown on the map. Well, for that one, I'll need to go into my ESRT. So let's go ahead and pull that up. So we're just going to match this map symbol here. So this is a stationary front being shown close to Tampa. And 78 asks to describe one piece of evidence shown on the map that indicates Tampa, Florida has a high probability of precipitation. Well, there's a couple different things that we can use here. One is it is relatively close to a stationary front, so they could be experiencing some overcast and some precipitation for a few days. Also, if we look at the air temperature and the dew point, they're very close together. So that means that the air is going to be really, really humid and just about to rain because that dew point is so close to the actual temperature. And then when we see the cloud cover, it looks like there's 100% cloud cover in Tampa too. So a number of different reasons that we can conclude that Tampa, Florida has a high probability of precipitation. Let's get rid of some of these drawings here and we'll continue. We'll look at the next question. So this one's from the June 2018 Earth Science Regents. 66 asks, describe the evidence shown on the map that indicates the highest wind speeds occurred near Watertown. We did this one in our last video, but we see those isobars are very close together. Another station mile. 68. State the compass direction toward which the center of this low pressure system moved over the next 2 days if the low followed the normal storm track. Well, our normal storm track is going to be weather moving north and east because we're going to have maritime tropical air mass pushing the air north, and then we're going to have those continental polar air masses coming down from Canada and pushing things eastward. So if this continues in the normal storm track, we would expect to see this low pressure area move north and east. Let's take a look at another question having to do with storm tracking and predictions. So 44 through 46. 44 says this is from the January 2019 regions. If the center of the low pressure system follows a normal storm track, toward which city would the center of this low likely move? Well, here's our low pressure system, and the normal storm track is north and east, so we would expect this low pressure to move towards Plattsburgh. For 66, it says, which map shows the most probable areas of precipitation that would appear on a radar image at the time of these frontal positions? Well, we get precipitation around fronts. So the best map that shows us that would be map 3. We do get some lousy weather around low pressure areas, but the precipitation is going to be right along the fronts. So the best option there would be choice 3. Okay, let's take a look at 3 of these questions from the June 2019 regions. We've already done a station model in this video, so we don't have to do that. But let's take a look at 54. It's asking, describe the change in air pressure that will most likely occur at Rochester by the time the cold front has reached Syracuse. Then describe what will most likely happen to the amount of cloud cover in Rochester with this change in air pressure and location of the cold front. So in order to understand what would happen, remember that a cold front is created when a cold continental polar air mass is moving south and east. Now, once this front reaches Syracuse, Rochester will be in the middle of a continental polar air mass. And what type of air pressure would come from a continental polar air mass? Well, if the air is cold, that means that the air is going to move downwards, and that's going to create a high pressure area. So we're going to see an increase in air pressure after the cold front passes. And if there is an increase in pressure and the air is moving down, that means that there's no lift to create moist air and to create clouds. So we're going to see a lower amount of cloud cover once that cold front passes for 54. So we have increased pressure, decreased cloud cover. So we can put that in here. Increased air pressure, decreased cloud cover. 55, we've done station models already in this video. Hopefully you're already an expert at it. Just remember that abbreviation, it's not 010, we want to put a 10 there to change that to 1001.0. Let's take a look at 56. State the relative humidity at Albany when the air temperature is equal to the dew point. If the air temperature is equal to the dew point, it means that when this person swung their sling psychrometer around, there was no difference between the wet bulb and the dry bulb. And if that's the case, if the dew point is the same as the air temperature, that means that there must be a 100% relative humidity. That's what they were looking for 56. Has to be 100% if it's equal to the dew point. And lastly, 57, identify the name of the weather instrument used to measure the wind speed at Plattsburgh. It's the name of the instrument that's used to measure the wind speed anywhere. And my favorite word in earth science is the anemometer, but you also could have called it a wind gauge. You could have called it a windsock. I've even seen a wind meter be accepted as a correct answer. But if you want to impress your science teacher, call it an anemometer. It's my favorite word to say too. Don't forget about these jet streams. They're also going to influence weather. So I like this diagram just because it shows us clouds forming where the warm, moist air is rising, especially close to the equator. And then we have clear skies where the air is coming down. So compared to the subtropical jet stream, which is over here, the polar front jet stream is, well, it's closer to the North Pole, so it's at a higher latitude. And it looks like it's closer to the surface, so it will be a lower altitude. Let's take a look at how those jet streams influence air masses. So 2 more questions. This one's from January 2016, and it's just asking us to show, to show the air mass movements associated with this jet stream position. So which air masses are being created here? It's not maritime over land. It has to be maritime over sea, tropical coming from close to the tropics, continental polar coming here from Canada. This tropical wouldn't fit in this top one, and this polar one wouldn't fit in this bottom one. So the best answer here would have been choice 1. Last question. This one's a little bit different than the other one, so we'll read the instructions. It says the map shows a composite of Doppler radar images. The darker shadings indicate the precipitation pattern of a large system over the eastern United States. 3 questions to answer here. The surface wind circulation pattern around the center of the storm is, so remember the clock is high and the counter is low. We're going to have, since we're seeing this storm right here, we have kind of lousy weather. So that means that we have a low pressure system. So if it's a low pressure, I'm going to expect it to be moving inwards. Remember, the clock is high, the counter is low. So the best choice here would have been choice 2, inward and counterclockwise. And we can kind of see that counterclockwise happening here with the way that these clouds are forming. 43, the best evidence on a weather map to indicate high speeds. We already know that that would be isobars drawn close together. And lastly, if the storm follows a normal storm track, it will most likely move towards the, and we know that it usually moves towards the northeast. So we would expect it to move that way. Okay, that's it. This is the last video in the unit, so I'll see you next unit. Have a nice day. Bye.